Two linear functions are shown together with a shaded region between them. So how would you find the area of a shaded region between two curves? Well, first off, line 1 has points 0, 0, and 2, 1. So they mean line 1, they mean this black one here. So this one they're calling line 1. Because how do I know? 0, 0, and 2, 1, right? So what's the equation? Well, how do you find the equation of here, line 1? Bring it up here. Well, you got it's y equals mx plus b, right? Because the line. So just x to the first power, y equals mx plus b. So what's the slope? So, well, actually, what's the b is the y-intercept. You can tell the y-intercept. It hits here at a height of 0. Hits the y-axis, this is the x-axis, at a height of 0. So that's just 0. The slope is rise over run, right? That's what m is slope. So how do we find, so what is the rise and run? Well, you'd go up 1 over 2. Up 1 is the rise, over 2 is the run, to go from point to point. Up 1 over 2, x plus 0. So there's the equation of that one, which is what they got. All right. And then next, we're going to do line 2. So this one, that's going to be line 2. And again, it also is y equals mx plus b. It hits up here at 7, so that's its y-intercept. Its slope, it's going to go what, down 1, 2, 3. So down 3 is the rise, and then over 1, 2, 3, 4. Over 4 is the run. So down 3 over 4, x plus 7. They put the 7 in the front, but same thing. That's right. That goes there. This goes there. Okay, now, so how would you do the integral to find, how would you set up the integral to find that area? Well, you would have to go, let me erase this now. You would have to go from where they start to where they intersect. So they start here at 0, but they intersect right here and somewhere between 5 and 6. How do they find out where that is? Well, to find the intersection point, that's a little tricky. Let me show you. So to find the point of intersection, what you gotta do is set those two equations equal because you want to know where does y equals a half x equal y equals minus 3/4 x plus 7. Like where do they meet? Right there. Where are their heights the same? So just say a half x equals minus 3/4 x plus 7 because you want their y values to be the same there and their x values. So you're saying this y equals that y, meaning this equals that. So solve for x now. How do you solve this equation for x? Well, I'm going to get rid of all the denominators first. I'm going to multiply through. Well, how do I choose 4? Because 2 will go into 4 two times. That's 2x. 4 will cancel 4, leaving minus 3x plus 28. Let me slow that down for a minute. I know that's a little bit challenging for a lot of people, but you want to get more and more used to that with fractions. What did I do? I looked at that 2 and that 4, and I thought I want to get rid of them. So what do 2 and 4 both go into? 4. That's called the greatest common denominator. So then, but when you multiply the 4, you got to do this guy also, all 3, because you got to do equal treatment when you have an equation. Whatever you do to one part, you got to do to all the parts on the other side also to keep them equal, to keep the balance. I had to do 4, 4, 4. This one just became 28. But the other two canceled. 2 went into 4 two times, 2x. And 4 canceled 4, leaving only minus 3x. See how it got rid? See how that denominator canceled and that denominator canceled? We have no more fractions. That's the beauty of it right there. Now let's get x alone. No more fractions. It's much easier to deal with this thing. Add 3x to both sides. We've got 5x equals, these are canceled, 28. Last step to get x alone, divide by 5, boom. So x is 28 over 5, which is 5.6. If you check it on the decimal, and that's what they got. That's that point of intersection. This is at 5.6. So we need to go then, the integral needs to go from 0 to 5.6, from 0 to 5.6 of the top function minus the bottom. That's how, when you want the area in between two things, you've got to take the top minus the bottom. Let me do that right here. So this integral is going to be the top line minus the bottom line. That's how you find the area between. Area of the shaded region will be the top line, so that this top line minus this bottom line, and you'll get the area in between. So what's the top line? Well, that's the line 2. That's this one, minus 346 plus 7. So let me write that one down. The blue one is the minus 3/4 x plus 7. So that one minus the bottom one. The bottom one is line 1, the bottom right there, and that is the half x. So you got to subtract those. So you could, so they just typed it in. They put the 7 in the front, minus 3/4 x, right? Minus a half x. And there we go. So that's what you'd have. Now, we never found the answer. Like, we never found out what is that area, but we set up an integral that we could use to find that area. The integral goes from 0 to where they intersect at 5.6. Of the top minus the bottom gets the area in the middle. And there it is. There's the top minus the bottom. And so there we go.